Hi. So there is this question from IGCSE Physics 0625, paper 4 from the year 2011, which is a difficult one. It's a very interesting question, and we are going to discuss it today. Let's see. So it says that tsunami is a giant water wave. It may be caused by an earthquake below the ocean. Waves from a certain tsunami have a wavelength of this much and a speed of this much. Calculate the frequency. Well, we are going to use the formula for it. That's not a difficult thing to do. Frequency V is equal to F lambda. That's a wave equation. So we're going to use this. We're going to try to make F, the frequency, the subject. So it comes out to be V divided by lambda. And speed is given to us 240. And the wavelength is also given to us 1.9 into 10 to the power of 5. Well, we can divide these two to figure out the frequency. Let's see. So you've got 240 divided by 1.9 uh, comes out to be 1.3 into 10 to the power of minus 3 hertz. Well, that is your answer for 2 marks. But that's not the difficult part. We're going to keep the speed in our memory for the part that comes next. So speed of the tsunami was a 240 meter per second. And let's see what it says here. Well, it says that the shock wave from the earthquake travels at that speed, and the center of the earthquake is 6 into 10 to the power of 5 kilometers meters away from the coast of the country. Okay, uh, so there it is. That's the epicenter. And this epicenter from the coast is 6 into 10 to the power of 5 meters, around 600 kilometers basically, from the coast. And the shock wave from the epicenter through that Earth's surface travels at the speed of 2.5 into 10 to the power of 3 meter per second. Okay. And we also know that the tsunami travels at the speed of 240 meter per second from the previous part. And the distance, of course, from the place the tsunami is generated to the coast is the same, 6 into 10 to the power of 5 meters. Okay. Now they say how much warning of the arrival of tsunami at the coast is given by the earth tremor felt at the coast. And they said warning time equal to how much? And the at the bottom of the question, this was asked warning time and fill up the warning time. So the thing is, when the earth tremor travels all the way through that surface and reaches the warning system at the coast, that's where the alarm will be triggered. That's where the alarm will be triggered for the people to evacuate the beach. They're asking how much time do they have? What is the time difference between the earth tremors reaching the warning system and the tsunami reaching the coast? What is the difference? And that would be the warning time given. So it's pretty simple from there. You know that the time taken by the tremor is supposed to be the distance divided by the speed. So 2.5 into 10 to the power of 3. It comes out to be 6 divided by 2.5, around a 240 seconds. That's what it's gonna be. And the time taken By the tsunami to reach the coast, it's the same distance, and the tsunami travels at 240 meter per second. So let's see. 2500 seconds. And that is how you can figure out the time the time the people are given to evacuate the beach is the two values that you've calculated subtracted. So warning time is going to be 2500 minus a 240, and it comes out to be 2260 seconds. Yes, that is your warning time. So the question was to calculate how much time it's given for the people to evacuate. See, once the earth tremor reaches the warning system, that's where the alarm is going to be triggered. And once the alarm is triggered, people have about this this amount of time to vacate. I think it's about 37 minutes. Let me just divide it by a 60. Yes, it's about 37.67 minutes for them to evacuate. And I think 37 minutes is good enough. Let's see. So that was the question. That's all. Thank you.